Amrumbank West, the location of a future offshore wind park. This is the North Sea, 36 kilometers southwest of the island of Amrum. The sea in this region is rough, with wind speeds of up to 110 kilometers an hour and waves up to 17 meters high. But it is at sea, says the experts, that the future of wind energy lies. On land, suitable sites for wind turbines are becoming scarce. Out here, the wind blows more steadily, more often, and with greater force. Advantages that outweigh the high cost of offshore wind energy. Amrumbank West GmbH, owned jointly by E.ON Energy Projects and Winkler Energie Hannover, wants to construct an offshore wind park in the Amrumbank area. What are the business and technical requirements for a wind park here? Will the investment pay off? Answering such questions calls for hard facts, data on wind, waves, and weather, and for that, a Windmessmast is needed, right in the middle of the North Sea. Who are the specialists capable of handling such a complex project? They form a team, experts of 3 companies collaborating in the joint venture Windmessmast Amrumbank. Lead management is carried out by Hochtief Construction. The company operates worldwide. Hochtief benefits from its extensive know-how in dealing with challenging construction projects. Steel construction is in the hands of IAG Industrieanlagenbau Georgsmarienhütte. For transport and offshore installation, there is the jack-up platform JB1, provided by Muhiba Marine Engineering, Germany. The Windmast will be erected on what's called a monopile, a massive steel pipe. On this comes a cabin equipped with all the requisite metering and control devices. On it stands a steel latticed mast towering 90 meters above the water. The entire construction has a length of around 130 meters. The internationally renowned IAG Industrieanlagenbau Georgsmarienhütte Limited Group manufactures apparatus and tank construction with a particular focus on welded structures for industry and environmental protection. In Antwerp, work starts on the fabrication of the 70-meter-long monopile. It is made in 3 sections and has a total weight of about 290 tons. The raw material is specially tempered offshore steel, up to 78 millimeters thick. Only top-quality steel will do. The order numbers indicate the origin of each individual part. The material is shaped in a computer-controlled bending press. The task facing the specialists is to convert the workpiece, 17.8 tons in weight and 3 meters across, into a structure that is absolutely round. After bending, the 3.5-meter diameter segment is provisionally tack welded. Then, in a series of steps, the thick-walled pipe formed in this way is longitudinally welded inside and out. The monopile has to be driven 23 meters deep into the seabed in order to withstand the enormous force of the waves. The completed structure will rise 90 meters above mean sea level and will have to brave the elements. Each completed part is subjected to a visual, ultrasonic, and magnetic inspection. The 3 sections of the monopile are transported to Bremerhaven by truck and assembled at an IAG site. Both ends are sealed with waterproof caps, because from here, the monopile will float to its offshore destination. A transition piece will connect the monopile with the measuring cabin. The measuring cabin is the control center for more than 30 metering devices installed along the total height of the mast, above and below water. The design and fabrication of the latticed mast represent a major challenge for the engineers and assemblers. Above all, perfect welding is essential to ensure that the filigree steel structure can withstand even the most adverse weather conditions. The pipes are cut and fitted exactly according to plan. By itself, the steel latticed mast is some 60 meters tall. Later, it will be installed on top of the transition piece to bring it to a total height of 90 meters above mean sea level. Because of its dimensions, the mast is fabricated in several parts, and transported by inland vessel to Bremerhaven, where the parts are assembled to form 2 mast sections. On the extension arms, which are up to 7.5 meters long, technicians install metering devices at 8 different levels. In the meantime, the heavy hydraulic hammer that will drive the monopile into the seabed has arrived in Bremerhaven, ready to go into action. The jack-up barge MEB JB1 is waiting in position in the harbor. It's operated by the Mohiba Marine Engineering Company, Germany. The company has a wealth of experience in the field of offshore installation. The platform is 50 meters long and 30 meters in breadth. Its main tool is a rotary crane, which can handle loads of up to 270 tons. Everything goes on board. The pre-assembled measuring cabin, both segments of the lattice mast, and the hydraulic hammer are carefully loaded and firmly secured to the deck for transport to the location. The piling frame, which will later guide the monopile during the driving process, was specially designed for this mission. Offshore work demands excellent logistics and perfect preparation. Another factor in this case is that the assembly of the Windmessmast has to be carried out at a great height. Tool and component handling has to be kept to an absolute minimum. So boxes containing all the required material have been made ready before leaving the harbor. The monopile is ready and waiting in the harbor basin, with its ends sealed by custom-made caps. The heavy towing gear has already been fitted. According to the weather forecast, the sea will be calm in the next few days. The project management gives the go-ahead for the offshore installation of the Amrumbank West Windmast. As it puts out to sea, the tugboat towing the jack-up platform to its destination is supported by a harbor tug. Under the supervision of the harbor pilot, the platform is carefully maneuvered out of the harbor. Passing through the lock is a precision operation. The monopile is towed by 2 additional tugboats, and they set off. Course, Amrumbank. The following morning, the tug and tow at the jack-up reaches its destination. The sea is still calm, but there is dense fog. The jack-up must now be positioned and anchored exactly over the location for the monopile. This can only be done during tidal slack water, the short period between ebb and flow. At any other time, strong currents would make this operation impossible. At just the right moment, the jack-up captain gives the order to drop anchor to secure the platform. The tugboat then maneuvers it exactly into its required position. To place the Windmast accurately, the piling frame for the monopile must be aligned precisely north-south. The position is correct. The JB1 lowers its 8 legs to the seabed. Each leg is manually controlled by a separate helm stand. The jack-up process begins. The platform is raised and leveled out at its operational height of 17 meters above mean sea level. The tugboat has completed its work, but it remains within visible distance. To ensure traffic safety, another ship circles round the position. The following morning, the divers arrive in the Aurelia, the diving base vessel. Their first job is to detach the monopile's bottom cap. The Aurelia must be positioned as close as possible to the jack-up platform. The tugboat assists in this maneuver. Calm seas but dense fog again. The lifting of the monopile by the JB1 crane can only be attempted every 6.5 hours, when the currents ease for a short while at slack water. Clear visibility is essential. Right now, though, visibility is down to less than 50 meters. This is the most difficult part of the operation. The platform and tugboat crews have to cooperate very smoothly to guide the 290-ton monopile into the piling frame before the hydraulic hammer can go into action. Will the plan of the Hochtief-led team work or not? Towards evening, the fog lifts. Working together, the tugboats can now get the monopile into position within reach of the crane. The tugboat crew start changing the shackles. The handover from the towing gear to the lifting gear of the crane is effected via triangular plates. Each shackle can carry a load of up to 120 tons. Finally, the monopile can be erected. Still buoyant, it is lifted with a defined crane load and slowly guided into the piling frame. The wind is getting stronger. At the end of the operation, the monopile is suspended vertically into the piling frame, held in position by the crane and its own controlled buoyancy. The crew uses previously prepared chain blocks to secure the heavy-duty steel pipe. The weather is still rough. Teflon-coated retaining blocks on the piling frame protect the monopile from any damage. The monopile is held by the crane hooks at a gauge of 18 meters. Since the water depth is 22 meters, the divers have 4 meters of space to detach the clamping bolts on the massive bottom cap. The lower pressure inside the hollow monopile keeps the cap in place for the time being. Through 2 connections in the upper cap of the monopile, compressed air and water can be introduced. Slowly, the pressure inside the monopile is increased until the cap becomes detached under its own weight. The piling supervisor carefully checks the upright position of the monopile. He is responsible for ensuring that it is perfectly vertical. If it isn't, it will be impossible to correct this later during the pile driving operation. Water is pumped into the body of the monopile as it is lowered down to the seabed. By further reduction of buoyancy, the lower end sinks into the sand. This has to be done slowly to avoid disturbing the seabed unduly. The crane basket is lifted with a separate rope next to the main hook. Working at a dizzy height, 2 assemblers remove no longer needed installation supports from the monopile. Then the upper cap of the steel pipe is removed. Now it's time for the hydraulic hammer to go into action. The critical question: what frequency and what force will produce the perfect result? The crane driver places the hammer onto the monopile's upper end. A 30-ton piston, hydraulically accelerated inside the hammer, drives the monopile 23 meters deep into the sandy seabed. Now the measuring cabin, with the pre-mounted transition piece underneath, is placed onto the flange of the monopile and bolted to it firmly. The first segment of the steel latticed mast is also positioned and carefully secured. The upper segment of the mast is assembled. With the second part of the mast, the entire construction reaches its final height of 90.94 meters above mean sea level. Soon the metering instruments will start to gather data. The measuring cabin is put into operation. Several computers collect the measurement data and transmit it by radio and by satellite to be evaluated on land. The pyramid-shaped oceanography sensor is put into the water and anchored securely. It collects data on the height of the waves, currents, and variations in sea level. 400 sand-filled scour protection sacks, each weighing 1.5 tons, are waiting in the harbor to be transported to the location and placed all around the mast. The scour protection prevents seabed erosion and ensures optimal bedding for the pile. With the help of divers, the placement of the sacks of sand is checked. Correct positioning is documented on video. Small wind power and solar systems supply electricity for the mast. and there's a diesel generator ready for use if needed. The consortium's project was successful. The Windmessmast is standing at position 53 degrees 30 minutes of northern latitude and 7 degrees 43 minutes of eastern longitude at Amrumbank West. Now, the experts eagerly await the data the Windmessmast will supply.